Hey everybody, this is Professor Turner again with Purdue Polytechnic, and today's video topic for ECET 364 Fundamentals of Electromagnetics is the use of bounce diagrams, which are a method to understand how electromagnetic waves travel in a conductor, and in particular what happens when an EM wave traveling in a conductor changes medium. So what I mean by this is say we have some sort of voltage source, and that voltage source is to travel along a length of transmission line that is long enough that there's some appreciable delay between point A and point B when that electromagnetic signal propagates. Well, what happens when the electromagnetic wave gets to this point? And that's going to be really the subject of this video series and the next video series. In getting from here to there, we've got 4 learning objectives that we're going to address. The first is that we're going to look at how electromagnetic signals are delayed in transmission lines. And we're going to relate this to what we call passive electric circuit properties, such as resistance, inductance, and capacitance. And then we're also going to relate this to material properties of whatever material the electromagnetic wave is traveling in. So that's the first learning objective. The second is that we're going to characterize conductors that are used to send signals in terms of a quantity called the characteristic impedance. And the characteristic impedance is a quantity that determines the ratio of the voltage to current in a conductor. So it's a little more complicated than just Ohm's law like you're used to. Now we have this new term called the characteristic impedance, and we'll use known geometric relationships and known material properties to calculate the characteristic impedance for different common conductors such as coax or twin lead or different types of conductors that you may be already familiar with. So that's the second learning objective. We'll then look at what happens when a signal reaches a change in material or a change in impedance between 2 parts of a circuit. So we call this an impedance boundary. And what happens when an electromagnetic wave encounters an impedance boundary? We'll look at that, and then we're going to look at how an impedance boundary can cause an electromagnetic wave to be reflected. So that's the third learning objective. And the fourth is that we're going to visibly or visually represent these reflected waves in terms of voltages and currents on transmission lines, and we're going to draw them is a function of both time and distance, and this drawing is called a bounce diagram, and we'll use the bounce diagrams to calculate the voltage and current values on a transmission line for DC inputs and for pulse conditions. So that's the fourth learning objective that we have for today. So that's what we're going to cover.